Hi folks, are you ready? I would like to introduce Tomáš Tomeček, who is the part of the modularity team, and his talk, Containerization, the best practices, worst practices.
So hey, I hope that you had a great lunch. Thank you for introduction, Peter. So I'm Tomáš. So as Peter said, I'm on modularity team, and my focus is containerization, actually. So hence the talk, containerization. So usually everyone is making talks about best practices, like best performance, elegant solutions. So and I realized, like, okay, let's try the other way around. Let's try with worst practices. So hence the talk. So what we'll be doing today? So we'll be doing worst practices, most of the talk. And then I will tell you why they are worst and what's the best way to do it actually. So just this is the agenda. In the worst practices, we'll cover several topics, which are the most commonly being misinterpreted or something like that. So it's like 6 or 7 topics. So, but first, please don't try it in production. I mean, they are really worst practices. And if you try, I mean, it's okay to try it at home, but don't try it in production. I mean, seriously. So what we'll be doing, we'll be actually creating an Nginx image. And we'll be doing the worst way ever. So let's do it. So before we start, we need to figure out the platform, what we'll be using for our image. So in context of Docker images, this is called base image. So and how do we pick it? So these base images, they are just tiny Linux distributions usually. There are all sorts of variants. And if you open Docker Hub, you'll see tons of images, and you have no idea how to pick the right one. So what is the criteria? So for me, the first thing is that I usually pick the thing I know. So for example, I use Fedora, so I use Fedora images. If you know something else, pick the thing you know. Also support, and what happens if there is a CVE in the image? Will the distribution update it? Will it be updated tomorrow or in a year? Or it's already 5 years old, full of CVEs? So these are all the criteria for picking the base image. And then once we pick a base image, we need to install the software itself. So in our case, it's Nginx. And again, I mean, we can pick it from distribution, or we can compile it ourselves. It's pretty much up to us. Okay, so let's start write the Docker file. So this is what we pick. The worst thing you can pick is just random image you found today, and everyone's talking about it because it's new and cool and secure, and it was released yesterday and it's still in beta, but you can use it in production. So that's, for me, that's the worst thing to do. And when you pick this obscure platform or whatever it is, usually it's hard to install something inside. So you just Google okay, how do I install Nginx? And you find script, and it's okay, it solves my problem. So I just curl it and I pipe it into bash, and it's just running, and everyone is happy. But as you can see, it's the URL is pretty long, right? So let's use Bitly and just shorten it. I mean, this looks way nicer, right? So yeah, so we have the software, great. I mean, let's run it. Before we run it, we need to figure out configuration. So usually in these days, most of the services are configured with config files. So yeah, that's the standard. In case of Docker images, most of the people, what they do is that you can configure the image by passing environment variables. And then when you start the container, there's init script running, which parses all the environment variables and prepares the configuration and then runs the service. This is the usual, and it has pretty nice user experience. So other way you can configure it is that you will prepare the config yourself, and you just either mount it inside the container, which is okay for one node, but if you are in cluster, you don't want to SSH into the node and put configs there, and or the other option is to just overlay it. So you basically pick the image, add the config, and that's your customly created service with custom configuration. That's also okay. So all of these options have ups and downs, and it's really up to you to pick the right one. It's configured. We need to start it. As I said, like you can either start the service with the binary, or you can write some script which will do something and then start the service. So these are all the options. Yes. So how we do it the worst way? So the worst way regarding configuration is like, just don't configure it. I mean, okay, or make it hard for people to configure it. The way you put there some really complex script, and if the people try to like configure it, it breaks and it doesn't work, and you find like thousands of issues, like it doesn't work. So it actually happened to me like recently when I tried the WordPress and MariaDB image, which is official image on Docker Hub, and just didn't work. I mean, it's like, okay, it's the official image. So yeah, this is how you can like make things hard for everyone. And regarding starting the service, so let's say that our requirement is that whenever the service fails, we want it to restart it. So like in my opinion, that's the job of the orchestrator, right? So for example, Kubernetes, OpenShift, they should take care of it. But I mean, we can still install supervisor inside and let supervisor like handle the service itself, which is like another layer of complexity. So I think this is the worst thing you can do, but some people do it, and we'll see. So next topic, metadata. For me, this is super important, and I'm really sad that like no one figured it out yet, or like there is not much work being done in this area. So when you download an image from Docker Hub, the first thing you do is you open like the web page and read the README file and see what are the options and how to use it. So why this information isn't already baked inside the image? So why would I need to go to internet to see how to use this image? I mean, I want to have this data inside the image, and it's like no one does this. So yeah, when I download an image, how do I know what's inside? Like, how can I use it? It's like impossible. You need to Google it and find some documentation. It would be great if you could just do like man this image, and you would open a man page with all the data. So what's the worst thing we can do? Like, obviously, we can just don't write anything. Like, it's up to you to figure out what's inside. So if you're in a company and you maintain some images, and then you leave the company and you don't fill this metadata, and then next guy comes in and it's like, oh my God, what is this? How do I use it? Like, so is there anything which could be even worse? So how about we fill in wrong data? Like, okay, this is Nginx image, but actually it looks like it's a database and HTTPD, and it runs on this weird port. I mean, yeah, it can happen that you have bug in your infrastructure, or you just like, you had a bad day and you think you are in this repo, but you are in other repo, but like filling wrong data is really bad. Okay, what's next topic? Image size. Yeah, I could talk about this like whole day. This is like huge topic. So, but first we need to start with some like theory. So layers. Yeah, this is the technology, the way images are like, the images work. So you have all these layers, like one image is composed of 12 layers, and then they use copy on write technology to like layer it on top of itself, and you get a container. So you can imagine this very easily with Lego. You get 10 Lego pieces, like they're on their own, they are like, okay, one piece, but what do I do with it? I can't do anything. But if you want to build a tower from the Lego, you just put one piece, other piece on top of it, and then you get your tower, and that's actually your container. So that's the theory. And the most important thing is that each of the layer is immutable. You can't change it. Like, if you put something into layer, it will stay inside forever, and you can't do anything about it. If you have an image, push it to registry, pull it somewhere else. All the layers are being downloaded, and the data which is there is like forever. And that's super important. And like, so the only way to like change it is to actually rebuild the image again. And we'll get to that later, actually. So what affects the image size is these layers. Like if you put something which shouldn't be there, it will be there forever, and your image is just like getting bigger and bigger, and it has like 5 gigabytes. And you have like 10 versions of them, so it's like 50 gigabytes on your disk. That's definitely not what you want. So what are these data which usually reside inside? So for example, if you want to have an image and you want to compile the service yourself, so in order to do that, you need to put like all the compilers and dependencies inside the image, then compile it, and all these dependencies are actually like will stay there forever. So it's like not pretty good. Like, why do I have in my production Nginx image GCC? Like, I don't need that. So yeah, this is like all the redundant data which doesn't need to be there. So it's not just like build tooling, it's also like documentation or locale and that kind of stuff. Like, do you need it in production? Well, maybe, I don't know. Redundant services, as you saw, I installed supervisor D inside, and like, do I really need it? It's just like occupying space, and it's making it more complex. Like, I think it shouldn't be there. So how do we make this bad? So for example, we can do something like this. Like, we need to install several packages, and our developers love Z-Shell and Tmax, so they needed to have it in all the images, so we need to install it. And we can do it in like every installation in one instruction, which means like all the metadata will stay there, and then there's like next run and another new metadata, and like lots of metadata which is just useless and shouldn't be there. Let's continue. Okay, security. Yes or no? I guess no. So this is the example for security. Like, so we have this Git on our Amazon, and we have the content for the Nginx there, and it just listens on SSH because our security people are crazy, and we need to get it inside, but we don't know really how. So okay, so we just put all the like SSH keys inside the image. We clone the repository, and we actually care about security. So we remove the the keys, so like no one can like breach or get inside. And as you could see in the previous example, I was also installing SSH there. But like if you have SSH inside, you need to like authenticate somehow. So like you can either have like certificate there or just set like password for root, and just like easy and convenient. So let's just do that. So yeah, this is pretty much our image now. Okay, and I have a sad demo prepared for you. And the reason which is sad is not like the reason it is sad, it's not that it's like worst. It's other reason. So when I was preparing this talk, I had an idea like, okay, so I want to do like a really great demo, which like everyone would love. So I was thinking about it, like, how do I do it? So I realized like, okay, so I can create this worst image, which has some like vulnerabilities, and let all of you like pull the image and like find the vulnerability and like hack the system I want you to do, and then I could like make a competition, and so I brought these like prizes for all the people. So I tried it yesterday, like, okay, so I just try to pull the image, like if it works, and like have the cool demo for you. And I realized that the Wi-Fi in here is really horrible, and you can't like pull anything. It just times out, and so I realized I won't be having my super cool demo then. So yeah, it's a sad demo because I will just show you like why it's so bad, but I wanted to like had it like way better. Huh?
Will there still be prizes?
Yeah, definitely. So yes.
Like one.
Yeah. So just ask some like very good question. Okay, so let's proceed to the demo. And the demo is actually like I will show you the image, and I would like to show you like so the reason that it's insecure. I mean, I imagine that most of you know like what's wrong, but I would like to show you like really how it's so trivial to like if you have some vulnerability in your system, it's that it's so trivial to like break in and get access to the systems. So yeah, okay, and I need to put my terminal on the other screen. Yep. So can you see it? Bigger? Whew. Yeah, that's gonna be a problem actually because I'm running this super cool terminal emulator, ST if you know it, and you change configuration by recompiling it, so. So just give me 20 minutes and. Okay, that wasn't 20 minutes. So I can close this small one and have the bigger one. So is that better? Yeah, okay. So I already built the image, so we don't have to like spend 20 minutes here watching on the endless build. So this is the image. Yeah, it's here. As you can see, it has 900 megabytes. So it's like just with Nginx. And if we compare it, for example, to like Fedora 25 image, on its own is just like 200. So yeah, image size matters definitely. So okay, so we know that there is in maybe some layer the SSH key, and we want to get it. So what do we do? So first thing, like we have the image, we pulled it, and we need to like export it or like get the archive or get the image itself. So we do it with Docker save command. And right now what's happening, the Docker is getting all the layers and makes a tarball from it, and it just puts it inside a file. Yeah, it takes some time because 900 megabytes, right? Make our images small. So and once we have it, I'll show you like the actual layers. Okay, so right now I will open Midnight Commander, and here is our image. And so as you can see here are some like weird directories, and these are the actual layers, and there's like several of them. And then there is also some metadata. So as you can see, like Docker image is actually just like a list of like root file systems and some metadata. Like it's not rocket science. It's actually really easy. So and one of these directories have our keys. So let's see. So again, one layer is again like a root file system and some metadata. So we can still open it. And yeah, so you can see that this is probably the base image that has all the like file system structure. So that's not what we are looking for. So what's inside here? Well, that looks way better. Wow. Yeah, but these are not our files actually. These are whiteouts. So what whiteouts are that you could see that I was doing like rm the keys, and what's actually really been doing is that Docker will create these files, these whiteouts, which just tell the engine that, okay, so these files shouldn't be like available in the final container, so just like hide them or something like that. So our files are still there, but they are hidden. So, okay, this looks like dangling symlink. How about this one? Yeah, this is probably the one of the packages which were installed. Let's go even deeper. Still not it, probably. How about this one? Yep. Wow, here are our keys. Wow, so it wasn't that hard, right? It's like 40 seconds. So let's copy them. And, oops, yeah. So Fedora rawhide. Okay, so let's just reset our terminal so it works actually. And so let's try to SSH to the system. Like, okay, so I already. So as you could see in the Docker file, okay, so I'll make it the better way. So the way we get to the host name, so we can do Docker history, which will like show us all the traces or the way the image was built, and we also do these options so it doesn't truncate any output. So we have like everything. As you can see, like we can see all the commands which were used. You can also see that this is probably like Fedora image since here is Adam's maintainership. Yeah, and that's actually what the random image was, that I just took the oldest Fedora image I was able to find, and I just like make it a random image. Okay, so, but we need to find the host name of the system. So let's do grep. We know that it was like EC2 something. Yeah, it's in here. So we can do SSH .e our key root, I guess. And let's try it. Yeah, we are there. I mean, 2 minutes and you can like hack any system which has like SSH keys inside the image, and it's like available online. Yeah, and I also can't forget to tear down the VM so no one else can hack it. So this was my demo. It could have been way better. I'm sorry about that. So let's get back to our presentation. Yeah, just close it. So, and now we are getting to actually the best practices. So let's see what was so wrong about these weird examples. Okay, so the beginning, we used some like whatever obscure image, and we just found a script and tried to like curl it during every build and pipe it into shell. So what's wrong with this approach? So first thing is that like we made like our infrastructure on top of something which we don't know, probably don't even trust. So definitely like when you start like figuring out what's the base image gonna be for your services, like first pick something which you know, like if you are using, I don't know, Ubuntu, Debian, Fedora, like probably pick that, like you know it, you probably trust it since you are already using it. So pick that one, please. Next, if you want to install some software, so doing curl, which means that you do it like on every build. So what happens if someone changes the script and, for example, puts like, and would like to, and when someone changes the script and puts some like vulnerability inside, like wants to copy your keys and upload them to your server. So like make it reproducible, like download the script, actually see what's inside and change it or whatever, but just don't like do this. And the funny thing is that this is actually the installation method of Docker engine. It's like curl the script and pipe it into shell and install it. It's like, wow. So yeah, this is how you should do it. Like base it on something you know, and then when you install software, install it from like the trusted repository. So for example, for me, that's like official repositories for my distribution. And also, if you are planning to use it in production, like you don't have to install like all the documentation, that kind of stuff. Like for development, it's great, but for production, like you don't probably need it. You still have the man pages on your computer, and it's like probably the same thing which runs inside the container. Yeah, and regarding configuration, So as I said, like there are different methods to do configuration. So if you are in clustered world, it probably makes sense to overlay the images with your configuration, which is stored in your Git repository somewhere. Like because it's reproducible, you can easily change it, and you don't have any dependencies on the nodes. Like you probably don't want to host files inside the node. It's like not probably your pet. So yeah, overlaying is fine. And also, I mean, on the other hand, you can use the approach with environment variables. Like that's most of the people are using. It has very nice experience. You just set some variables and it works. So that's also fine. Yeah, metadata. So obviously, like put the correct metadata in there. It's also very nice to put like information. Like when your Docker files are stored in Git repository, it's great to like put the information about like which Git repository, what was the commit. So then it's like very easy. You can easily trace like to the time when the image was built, and you can see like the whole build environment which was like used for the build itself. What else? Yeah, in the other part of the example, so chain the instructions. Like you could see that like every this instruction created a new layer, which means that for DNF, like it downloads metadata and they will stay in the layer. So if you chain it, you can get all of the work done within one layer, and no files will linger in the final image. And same thing goes for the security bad example. Like the way you could do it is that you can like download the thing in one layer, then unpack it, install it, and then remove the archive because you don't need the archive in the final image. Okay, so yeah, this is the preferred way. Like put the correct metadata. Don't install like useless software inside, which just doesn't make sense. And if you need to like do some actions, like do it within one layer. And finally, so I wasn't much talking about like how to, like what's wrong with this. So the thing which is like wrong in this, like what Docker does when you have this in your Docker file is that it will create shell, and this shell will invoke this script actually. Like it's script, it's just like it's not for exec, which means that like your container will be actually like, so you have like parent process, which is probably something from the container engine. Then you have shell, and then you have like your service, which means that all the signals are being passed to the shell and not to your service, which is like not what you want, right? So you have your service, you don't have like shell running, like you didn't meant to run shell inside. So the way to solve this is that you can run the service as like exec and the service, which means that the exec will eat the shell, and there will be only service running inside your container. So please don't forget about it. It's like pretty important. Also, other thing is like reaping zombie processes, which Lukáš was talking about this on his workshop for systemd. So again, like the PID1 process should reap the child processes. I mean, this is like it's still not being like solved well. I mean, I think that with Docker 1.13 there is a new argument which okay, I need to drink and think about it. So in 1.13, you can say that use this binary to be like parent process for all my containers. And this parent binary is like a very tiny like C program, which is able to reap the child processes. So yeah, I think this is available with Docker 1.13, but until now this like wasn't solved. There are like multiple these tiny init system projects available, and I'm not sure like if anyone was using them or well, like if anyone had issues with zombies in containers. So yeah, definitely the way to solve this is that like invoke the service directly and make it in the exec form, so you are sure that there is no shell running inside your container. And also for security, like you don't need to run your container as a root. So like why would you do that? If there's some like security vulnerability in kernel and the user is able to escape like from the container to host, and if it's already root inside the container, it's again root on the host system. So definitely change the user to some unprivileged user. Yeah, and that's actually it. So yeah, in 30 minutes, this was pretty fast. So the slides are available on GitHub. Also, the demo I built is on GitHub, so if you want to have fun, you can check it out. So if you are interested, like more best practices, within the project Atomic, we have this guide called Container Best Practices, and it contains like way more information than I just provided. It's like really like database for best practices for containerization, so definitely check it out. And if you like hook up with me, it's my Twitter handle, so just say hi. And I'll take questions and provide some like stuff from Red Hat for you. Yes, Peter?
Slide 18, I guess. You mentioned in Docker file free labels, directives. Does it make sense to have there on one line or all 3 lines?
Yeah, so the question was if it makes sense to specify labels on one line, like within one instruction or multiple. So the answer, yes, it definitely makes sense. I mean, that's a good point. Like you can even chain instructions or like label or env or stuff like that. So the way, but there's not the only answer. Also, this got changed within like Docker engine. So usually in like 1.10 or 1.9, like every instruction costs a new layer, even like changing metadata, which obviously doesn't make any sense. But then they changed the like data model of images. So right now with latest versions of Docker engine, a Docker image is actually composed of like list of root file systems and metadata. So changing metadata no longer causes new layers. So yeah, I mean, it definitely makes sense to do it on within one instruction, but it's like no longer needed. So yeah, you can pick any price you want. Any other questions? Yes, Luboš?
So it's obviously good to reduce the number of layers. So when you have multiple instructions, you should combine them into one, right?
Yes.
So is there some tool that can do this for me? Because it's slightly more readable if it's split into multiple instructions. Like, can something merge that into one thing?
Mm-hmm. Yeah. So the question is that if you had a shell script within one layer, it's not easily readable, right? And like if there is some tool to help with it. So what you can do, you can either make it on one line and it will look ugly, or you can actually put it inside like external file and have it like nicely there and just add the file into the container. It's also fine. And I'm not aware of any tooling for doing such a thing. So again, big pen or yes?
You said something like new Docker version, there's some option to set parent to prevent zombies. Which component is responsible for this? It is Docker daemon or it's systemd or what component?
So the question is, what component is responsible for ripping zombies in the new version of Docker, right? Okay, so it's actually a pretty funny story. So when they started approaching this problem and when they tried to solve it, they first wrote it on their own. So they created like a new project for that, just like a little C binary, which like all it was doing, it was just executing and then ripping, like very simple thing. And then at some point they completely scraped it and used like a community project for that. So yeah, it works like this. So you have the binary. on the system, and you tell Docker that, okay, use this binary to invoke all my containers. So it's like an external project. So if you ping me afterwards, I can even point you to like a real code or anything. Any more questions? Yes, please.
If we put the add layers, like if we put the files in different layers, like while adding them in container, so there will not be any difference in space or the size of the image, right? But it will slow down, or how do we differentiate? Like adding files in one layer versus adding files in different layers.
I'm sorry, but I'm not sure I follow the question, or like.
So what is the difference between adding files in separate layers, like multiple files in multiple layers, or adding files in one layer only?
Yeah, okay, thank you. So the question is, what's the difference between adding the files within one layer and within multiple layers? So, like more layers, the more, so the number of layers makes the like container startup slower, because if you have like thousands of layers, the kernel has to like merge these thousands of directories into one. It just makes it slower. So it's definitely like good practice to have as few layers as possible. So yeah, that's the main, probably the main answer. Any more questions? Yes?
If we really need to bake any passwords or keys into the image, is it advised to add them on a last layer or in any place?
So the question is like, if we bake some like files or keys inside, if we are advised to do it in last layer, like, or what's the best way to do it? So I try to dodge this project, this topic in the presentation, because it's, so the solution for this problem is like being worked right now. There was a talk about this on, I think it was yesterday, and it was held by Pavel Odvody and Christian, and I don't remember his last name. So they are working on a project which is like secrets management within containers. So they have a like separate service which holds all the secrets, so like passwords and keys, and they are working on a solution like how to integrate it with container infrastructure. So, and this is the reason why I didn't talk about it at all, that there was already a talk about this project. So definitely like check it out. It's called Custodia, the project. So, and then you can just like integrate your application with this service, like just, so you don't need to care about like putting secrets files inside your containers, because your application will be integrated with the service. Any more? Yes, please.
Why you didn't use that upgrade before installing engines? In the best practices, it's like I would like expect to first upgrade all possible dependencies already in the image.
Yeah, thank you for that question. It's a very good question. So the question is, like, why didn't I update the image with latest packages, right?
Yeah.
So for a long time, we were in Red Hat, we were not sure, like, what's the best way to approach this problem, like having latest packages inside the image. So for quite some time, we were updating the image with latest packages, but then at some point, we realized, like, it's not very good, because it means that it can actually break your image. Like, you pull an image, and you use it, and it works fine, and then you update it, and it's possible that like new update will break your image or your application. So then we realized that we need to treat images like an artifact, which so we need to treat them in a way that we don't update them. Like the update should be done like within the build system for the image. So if you need like new packages, you need to pull the new version of image, because it's like being tested like one artifact, and like the upstream or the vendor is sure that it works, so it delivers it to its customers or users, and everyone is sure that, okay, when I pull this image, it will work. But if you update the packages, like no one tested that, like it can break. So yeah, this is our strategy right now, that we don't suggest updating. Like within the build process, we don't suggest updating. I mean, there is also a possibility that there's a bug, and the easiest way is to update like packages or just one package. So that's like a workaround, but like we don't suggest updating images during build process. Updating packages, sorry. We have 10 minutes left. So any more questions? Yes, Langdon.
I just actually wanted to comment on it. That's not to say that you can't create your personal updated Fedora, say, and then you run all your images, use the from line from that for all of your other images, right? So, like, it's not that you don't update, it's that you don't update as part of the build process of that individual thing, because then you can't declare a particular state you're in.
Yeah. Okay, so I'll try to repeat that. Like, you still can like create new base image where you do the update and like base your images on top of this new updated image. But what we don't suggest is like updating during build process of like some layered image. So you can still like create new base image with updated packages. Like that was a good point. Thank you. Yes. So the question is, which version of Docker am I suggesting to use in production, or? Well, that's a good question, and okay, honestly, I'm an engineer. I'm not an administrator, so I don't use Docker in production on any server. So with this information, like, would you trust me if I told you, like, use this version, like, this one's best? So, like, what I can tell you is that, so Docker has, like, pretty quick, like, process of releasing new versions of Docker. And what's happening, like, quite often is that, like, one thing works in this version, then it doesn't work in your version, then it works again, and then again it doesn't work. And, well, like, Docker as upstream, they suggest, like, to use the latest version, like, all the time. So you can either go with that, or like stick to the version which like works for you. Because I remember back in the days when I was working on another project and we were like doing some service on top of Docker, we realized that, okay, so with 1.8 it works, and we upgraded to 1.9 and it didn't work. So it's like, so what are we going to do right now? And then we upgraded to 1.10 and it worked, and something else broke. So yeah, I mean, with most latest version, hopefully it works, but
Well, and also, I mean, RHEL ships a version, right?
Yeah.
So there is a supported version. So, you know, as a Red Hat employee, I would recommend that you use the RHEL version.
Yeah, that's so to elaborate on that. So what we do in Fedora and RHEL with Docker, we have like a version, and we try to put a lot of fixes which are even not in upstream version of Docker. So let's say that someone fixes in like developer branch in Docker some bug, and we cherry pick it into like the latest stable version. So actually, I think that like our version of Docker in RHEL and Fedora is even more stable than what Docker has, like, because we like fix and we fix all the bugs which are in latest or whatever version, and we backport them into like last stable version which we have in Fedora and RHEL. Yes?
What do you think about the colon latest tag? Do you think it's an anti-pattern or anything?
Yeah. So the question is about the latest tag. Yeah, that's also a good question. So again, in best practices, I hope that we have there that we suggest using like custom tag to not use latest. I mean, the latest tag is really convenient. Like, okay, so I want to pull this image, but I don't know like what version, so I just the latest and hope it works. But in your images, we definitely suggest to like pin to a specific version, so you are sure about the API within the image, you know that it works. And then when you think like, okay, there's like 2 new versions, so let's try with newer version. And then you can test your software, your whole application in the new version. And if it works, you can just upgrade. And if not, like fix it. And yes, Christoph?
I think we should not use any tags at all because it's just a tag. Everybody can set it. And I think in OpenShift we do something like reference the layer by its char-sum. So we know it's this layer we want to execute, whatever the tag is.
So Christoph's comment was to use like a specific SHA reference to the layer. So you are precisely sure what image you are running, because even with tags you can like override them and like break it. So yeah, that's a good point. That's what we've been doing back in the project to pin to a specific layer, like to ID. Any more questions? Yes, please.
You said you are not updating packages in the images. What about severe security holes in the existing package in container? Is it something like warning you should not use this image, or you are updating these particular problems?
So the question is about CVE, like known CVEs in images, right? And how to approach it. So I'm sure that in like atomic command we have like in Fedora and RHEL, which we use to manage like containers. So there is a command like to inspect an image and see if there are like any vulnerabilities inside. So like one approach is to like scan the image, and then it will show you all the erratas and CVEs which are inside, and then you can either like update it yourself or get the new version of the image. So yeah, that's one point. And again, like this is what I was talking about when I was talking about content. Like pick the base image which you really trust. Like if you trust Fedora, if Fedora is like that good that whenever there is CVE, there are new updates within a day. So yeah, pick something like that. And if you pick something else, which when there are CVEs, they don't just care, or they will release new images in months. So yeah, you can either scan or like pick a trusted vendor.
So what we do in the Red Hat container catalog is that we mark images as deprecated, right? So you can have a look at it, and obviously it's deprecated, but that's not a machine-readable information right now. It's just the administrator knows it's deprecated for whatever reason. And I think you need to scan this stuff. So if you're really looking into CVE, scan it, rebuild it. That's it. But never remove images from the registry, because you will break stuff.
So Christoph's comment to that was that in Red Hat Container Registry, Red Hat Container Catalog, we mark images as deprecated if they contain some CVEs. Yeah, and if you find such thing, you can still rebuild it and get latest packages, or like latest package to the where the security vulnerability is in. So we have time for just one last question. Yes, Ferro?
During this conference, we heard about several different ways how to avoid Docker files and build images differently. Builder and Ansible container and whatever. So using a classical Docker file, was it the best practice or worst practice?
Let's vote on it.
So the question is like, what's the best way to build images? Like if Docker files are good?
He was asking, is it a best practice or a worst practice to use a Docker file?
Aha, okay, that's a trick. Okay, so I think that you deserve a grand prize, like, for that question. Yeah, like Docker files are used mostly. I mean, everyone is using them, like, so the question was like, if it's best practice or worst practice to use Docker files actually. Yeah, so they are being used like everywhere, and so I hope that over time there will be many options to like other options to use it. For example, the Ansible container, as you mentioned, and we'll see like maybe in 1 year there will be something better. But right now we have to use what we have. Yeah, and that was last question. So thank you for attending my presentation, and I hope you like.
Yeah, thank you very much. And please don't forget to post your feedback and rating for this session. Thank you.